Okay, welcome back students. We are still in the topic of differentiation. Right, for the discussion today, we are going to talk about the chain rule and also the differentiation of exponential function and the logarithmic function. Now, before we start, let's do some revision. Right, in the previous discussion, we have learned about the product rule. So the product rule says that if we differentiate a multiplication of two functions, so this is what we do, right? First, we are going to copy the first function, right? Copy the first function, and we differentiate the second function. So the G primes state that we differentiate the second function, plus we copy the second function and we differentiate the first function. So this is the method we use to differentiate the multiplication of two functions. Now, for example, if we have y equals to x sine x, now as we can see here, we have x is a function and the sine x is another function. Therefore, right, we can use the product rule to differentiate this function. Now, we also learned that the quotient rule is to differentiate the division of two functions. Now, the division of two functions is something like, example, we have x plus 2 over 2x minus 3. So this is the difference, the division of two functions, right? We can say that x plus 2 is the fx and 2x minus 3 is the gx. So we have function f over function g. Now, to differentiate a function like this, so we follow this formula. First, we are going to copy the g. This g we copy. Then we differentiate the function on top. Minus, we copy the function on top. And we differentiate the function at the bottom. And after that, divided by the denominator square. So these are the two formulas that we learned in the previous discussion. Right, for today's discussion, we are going to learn another formula. It's called the chain rule. Okay, so at the end of this chapter, you should be able to find the derivative of a composite function using the chain rule. Now, it means that the chain rule, this formula, is actually used for composite function. Okay, we have actually a function inside another function. Then you can use the chain rule to differentiate. Now, after we differentiate, we need to know how to simplify the derivative, right, using the algebra method. And also at the end of this chapter, right, you should be able to know how to differentiate a natural exponential function, right? For example, y equals to e to the power of x. Right, so we need to know how to differentiate the natural exponential functions. Also, we need to know how to find the derivative of function involved in natural logarithmic function. For example, y equals to ln x. We need to know how to differentiate a function like this. And finally, we need to know how to differentiate the exponential function that have the basis other than e. For example, we have y equals to log 2x. So we need to know how to differentiate a function like this. So these are the objectives of this discussion. So we are going to start with the chain rule. Now the chain rule says that, right, so if we have a function like this, y equals to a function of x and a bracket to the power of n. So when we differentiate, this is what we do, right? First we multiply the power, the n. So we multiply, this is the power n, so we multiply the power, the n. And after that, the power reduced by 1. Now after we differentiate the power, we have to differentiate the function inside, Alright, so the function inside is ux, therefore we need to differentiate the function u with respect to x. Now I always call this onion. Alright, so why onion? Because onion has many layers. Okay, so when we differentiate, right, we first differentiate the layer outside. Now after we differentiate the layer outside, we differentiate the layer inside. Okay, so we differentiate the layer inside and we multiply. Now let's see some example here. Okay, we have a function here. This function is 3x minus 2x squared to the power of 3. Now we can see here we have actually two layers. Right, first we have a function, all right, bracket to the power of 3. This is a function. And after that we have another function inside, which is 3x minus 2x squared. Alright, so we have actually two layers. This is the layer outside and this is the layer inside. Okay, when we differentiate, we first differentiate the layer outside. So this is what we do. We have 3, we bring with 3, we multiply, and the power reduced by 1. So we have power 3 minus 1. Now, what should I write inside here? I should follow the original function here. It's 3x minus 2x squared. Okay, so we complete the differentiation for the layer outside. Now we are going to differentiate the layer inside. Okay, so when we differentiate this one, right, the layer inside, I have 3. Okay, minus, alright, differentiate 2x squared, 2 multiply 2, so we have 4, right, and the power minus 1 is x only. Now what happened? After that we multiply. Okay, so we multiply the differentiation of the layer inside. Now, so usually multiplication we do not have to write the multiply because the bracket itself, right, is understood as multiplication. Right, so in this case we have, right, 3 minus 4x and 3x minus 2x squared to the power of 2. Okay, so this is the final answer. Now let's look at the proposed solution here. Okay, so right, we let the u be 3x minus 2x squared. Alright, so this has been changed to u to the power of 3. So when we differentiate, so this is what we do, right? So we first differentiate the u. So when we differentiate the u, right, we have u to the power of 3 here. We bring down the 3, right, and then 3 minus 1, right, 3 bring down, the power reduced by 1, which is 2. Alright, so we have this. Now after that we differentiate the u. So when we differentiate the u, we have, right, so this is the u. Okay, so we will have 3. Okay, so this one is the u, right? So when we differentiate this, we have 3 minus 4x. Okay, so according to the formula, so we differentiate the u, then we differentiate u to the power of 3, and we multiply the differentiation of the u. Okay, so you can see here, right, we have 3, and change the u back to the function of x, and the du dx is actually this one. Okay, right, so 3 minus 4x, and this is the answer. This method is called the change rule.